Hello and welcome to a video on exam questions part 2, brought to you by the Answer series. Example number 1, there are 4 examples here. I want you to pause the video, I want you to try these, and then we'll look at them together. Question 1.1 is difference of 2 squares, so I factorize it and I get my 2 answers. Question number 1.2 again says to us, solve for x correct to 2 decimal places. So that gives you the hint that you need to use the quadratic formula. My a is 1, b is -5, and c is -2. So substitute into the quadratic formula and then use your calculator to get the 2 answers. Question 1.3 is an inequality. They've given it to you in factorized form with a 0 on the right-hand side. So don't multiply this out. You can use the brackets as they are, but just be very, very careful. This is a negative x squared, which means my parabola looks like that. My zeros are 2 and -4. So there are my 2 zeros. I want where it is greater than or equal to 0, which is this part over here. In other words, when x is greater than or equal to -4, less than or equal to 2. Question number 1.4. We're going to look at it in 2 ways. The first way is to take the 4 across to the other side and set up a quadratic. If you are able to factorize this, perfect. If not, then we're going to look at another way of doing it. This is a trinomial. You will notice your middle term has x to the power half, and your first term has x. So what goes at the beginning of each bracket is x to the half. And when I multiply, remember I add the exponents. A half plus a half is 1, which means I get back to my x. You want factors of 4, you want different signs, and you want -3 in the middle, which means I must have a -4 and a +1. 2 brackets multiply to give you 0, so one of them must be 0. So either x to the half is equal to 4, or x to the half is equal to -1. But if I think about it, remember x to the half is the same as root x. And in a previous video, we said root x by definition has to be positive, which means x to the half cannot equal -1. So my only solution is x to the half equals 4, square both sides, and I get that x is equal to 16. Now I know in this solution I can square both sides, but I'm not allowed to do that because by definition x to the half has to be positive. It cannot ever equal -1. Now, if you're not sure with the factorizing, what I can do is I can do it slightly differently. I can say let x to the half be equal to k. This is x to the half squared. In other words, it's k squared. This then becomes -3k, and I've got -4 equal 0. This is a much easier trinomial to factorize and to get my values of k. But I know that k is equal to x to the half, so now in place of k must go x to the half, and then I end up with exactly the same as I had in my first method. So whichever method you find easier, do it that way. Example number 2 is a simultaneous equation. I want you to pause the video, I want you to try this one, and then we'll look at it together. I take the linear equation and I make either x or y the subject of the formula. If I can avoid fractions, I do. So in this example, I'm going to make y the subject of the formula, and I get that y is equal to 2x plus 1. That y is exactly the same as these y's. So in place of these two y's, I'm going to put 2x plus 1. And that is what I get. Multiply the brackets, collect like terms. You'll notice that you can divide through by minus 3. So divide everything through by minus 3, factorize, and solve for x. Take your values of x and substitute back in here to get the corresponding values of y. And your solutions are x is minus 2, y is minus 3, or x is minus 1 and y is also minus 1. Example number 3. I want you to pause the video. I want you to try these two questions, and then we'll look at them together. 3.1 says write down the domain of f. Domain, remember, are the possible x values. Now you know that in high school maths we cannot take the square root of a negative, which means that 2x plus 1 must be greater than or equal to 0. So x must be greater than or equal to minus a half. This question is only worth 1 mark, which means I can literally write down the answer only. Question 3.2 says solve for x if f of x is equal to 2x minus 1. F of x was root 2x plus 1, and I make it equal to 2x minus 1. I have a surd equation, so I square both sides. Remember, when I square a binomial, I get 3 terms. Set up your quadratic, factorize, and get your 2 values for x. And then don't forget, in a surd equation, you have to check your answer back. So if x is 0, substitute into the left-hand side, and I get 1. If I substitute into the right-hand side, I get minus 1. Because the left and the right-hand sides are not equal, it means x cannot equal 0. What about if x is 3 over 2? I substitute into the left-hand side, and I get 2. Substitute into the right-hand side, and I also get 2. And because my answers are the same, it means x is equal to 3 over 2.
Check out the video description below for practice questions from our study guides. If you found this video useful, give it a like and subscribe to our channel so you don't miss any new episodes. Follow us on Instagram or Facebook to stay on top of the latest TAS news and launches. So that's it for now from the Answer Series, your key to exam success.